Alright, in this video we're doing questions 1 through 6 in the June 2015 Common Core Geometry Regents. We'll be explaining all these questions to you, so let's just get it started. So, question 1. Which object is formed when a right triangle RST is shown below as rotated around leg RS? So here's leg RS, and we're going to be rotating this guy all around and around and around. And what shape are we going to get? Well, I'm just going to tell you this. This is a level 10 question. This is where we learned about 3D shapes. And you might remember there's 3 different kinds of shapes that we rotate, and we get, if we take a rectangle and rotate it, we get a cylinder. If we take a circle and rotate it, we get a sphere. That's a 3-dimensional shape. And if we take a triangle and we rotate that, we get a cone. All right, so if you rotate these 2-dimensional shapes, you get one of these 3-dimensional shapes. So since we're rotating a triangle here, we get a cone. Do not take the bait and take the pyramid. This is what we call the distractor. Nice try. That's not what we're going to take, though. We're better than that. Number 2. The vertices of the triangle JKL have coordinates J 5, 1, K negative 2, negative 3, and L negative 4, 1. Which transformation is the image J prime, K prime, L prime not congruent to triangle JKL? Well, this is a level 1 question. That's where we learned about transformations. All right. I can't fit that in. Oh, so close. That says transformations. Now remember, we have rigid motions and non-rigid motions. Now, rigid motions produce congruent figures. And the rigid motions are, well, which ones have we learned about? 1, translation, right? That's just a slide. 2, reflection. That's a flip. And 3, we learned about rotation. And these are the rigid motions that we learned about. They make congruent figures. So these all make congruent figures. But the one that does not make congruent figures is a dilation. All right? And we learned that dilations are not rigid motions, but they do produce similar shapes, right? Because it preserves angle measures. But since we're looking for the one that does not produce a congruent image, we know that this is just dilations, right? Because that's the one that's going to make something that's not congruent. It gets bigger or smaller. It's a dilation. Duh. You're right. Let's move on to question number 3. In question number 3, it says the center of circle Q. You know what, hold on. Let me just do a little racing, guys. I just need to get this out of here. All right. Hopefully you copied that down. In question number 3, it says in the center of circle Q has coordinates 3, negative 2. If circle Q passes through R, 7, 1, what is the length of the diameter? Now, you might remember this. First thing you should do in this is just draw a little sketch. This is a level, oh, by the way, this is level 9. This is circles. But first thing is just draw a sketch. All right, so what they do is they've given us the center. This is at 3, negative 2. And it says that there's a point, this is Q. And this is a point R that passes through the circle. So this is the sketch. They gave us a center and they gave us a point out here. So this is our little sketch. And we're going to write a little note that says draw sketch. All right, so now that we've got our sketch, what's the next thing? We want to find the length and diameter. Well, what we know is this. If we find this length right here, that would give us the radius. And we can find that length when we have 2 points by using the distance formula. Remember, length, that's the key word here, and 2 points, we use the distance formula. So the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, well, let's just plug in our points. X1 is 3 minus 7 squared plus negative 2 minus 1 squared. All right, our distance is going to be equal to 4 squared plus negative 3 squared. And that should give us, well, that's 16 plus 9. We'll just go to 25. So the distance here is 5. So what we found is our radius is 5. And a lot of people are incorrectly going to be like, that's my answer. I did it. Nope, you didn't read the question carefully enough, and you didn't draw a sketch properly. It's asking for the diameter, right? So I also told you we should always just do two things. We're always going to state what the diameter is, and we're going to state the radius. We found the radius is 5, so that means our diameter is 10. Remember to fill out all that information so you're not making those mistakes. So sketch, diameter, radius found every single time. Nicely done, guys. Okay, question number 4. In the diagram below, which transformations are going to be mapped from figure 1 onto figure 2 and figure 2 onto figure 3? I mean, come on, guys. We got this. This is a translation. We're just sliding it over. And then our second transformation is rotation. I'm not even looking at the answer choices. I know those are the answers. But let's scroll down. Translation followed by rotation. Number 4. Listen, this is a level 1 question. This is transformations. I think we got this. All right. Number 5. Oh, this is level 6 where we learned about trigonometry. Level 6 trigonometry. Okay? Now we know the first things we should do is this. We always write down SOHCAHTOA. All right? And then we're going to label our sides. Those are 2 steps that we know we got to do. Label sides. And if you can do those things properly, well, hell, you'll do a great job. So this says if the point, so as shown in the diagram, the angle of elevation from a point on the ground to the top of a tree is 34 degrees. So here's the point on the ground. If the point is 20 feet from the base of the tree, this is the base, so we're putting the 20 over here. What is the height of the tree to the nearest foot? So we want to get the height of this tree. Guess what? This is x. So we're going to label our sides. And remember, you start with your angle. You go across like this. This is your opposite. Across from the 90 is the hypotenuse, but there's nothing there, so I'm not going to label it. And so that makes 20 my adjacent. So I have O and A. That looks like we will be using tangent for this problem. So we set it up like this. The tan of the angle, which is 34 degrees, is equal to the opposite, which is x, over the adjacent, which is 20. All right, we cross multiply this and we get x is equal to 20 times the tan of 34. When we get that in the calculator, we get something that looks like this, 13.5 feet. That is our answer right there. Sweet. Which figure has the same cross-section of a sphere? So remember, if I took a sphere, this is a bad picture of one, and you cut that with a sword. So you're going to take your knife, you're going to cut that guy. Oh my God, what a terrible picture. It doesn't even look like a knife. Ugh. You're going to cut it in half. What shape do you get? Well, you get a circle. These animations aren't helping us. So which one has the same cross-section as a sphere? Well, that would be a cone, right? Because if I cut this cone in half like so, I'm also going to get a circular cross-section. Answer here is 2. Cross-sections, you might remember, are just the 2-dimensional shape that you get when you cut a figure. Ugh, this is ugly. Ugly. And then finally, number 7. A shipping container is the shape of a right rectangular prism. That's going to be helpful. With a length of 12 feet, a width of 8.5 feet, and a height of 4 feet. The container is completely filled with contents that weigh, on average, 0.25 pounds per cubic foot. What is the weight in pounds of the contents of the container? Well, first thing, this tells us it's a right rectangular prism, so we're going to use the volume formula for that, which is just the base times the height. Now remember, base always means area of the base, so we're going to draw out our base, which is a rectangle, and we're going to say the area of our base is equal to length times width. Well, it tells us the length is 12, and our height is 8.5. So area is equal to 12 times 8.5. Our area is going to be equal to 102. Sweet. So now we go volume is equal to 102. That's my base. Remember, it's always the area of the base times the height, which is 4. The volume is equal to 408. And what feet to the cubed? Now to find weight, we're going to switch colors here. You might remember this. To find the weight, it's the density times the volume. Weight is just your density times volume. Now the density here is 0.25 pounds per cubic foot. Remember, per is our good indicator. That's a density measurement. So our weight is going to be 0.25 pounds times our volume, which is 408. And we get our weight is equal to 102 pounds. Done and done. And look at that. That's answer number 3. Oh, I went one over on this video. Well, You got lucky. You got 1 through 7 in this video. You're welcome, and peace.